Hi, I'm Cheryl Leach. In this problem, we're going to sketch a right triangle that has an angle theta, which happens to be acute, and when you take the sine of that angle, you get 1/3. After we do that, we're going to go ahead and evaluate the other trig function values for that angle theta. So let's go ahead and look at my construction. First of all, I want to draw a right triangle that has an acute angle in it. An acute angle is an angle that's less than 90 degrees. So my angle will be, the terminal side of my angle will be in that first quadrant. I also want the sine to equal 1/3. Well, one way that you can look at trig functions is you can think of them as ratios of the sides of a right triangle. In the case of sine, we look at the ratio, the opposite side over the hypotenuse. So when I draw in my angle theta, and I create a right triangle, I want the opposite side to have length 1 and the hypotenuse to be 3. Okay, so now let's go ahead and take a look at my trig function values. Well, I already know that the sine of theta is the opposite over the hypotenuse, and so that's 1/3. If you notice, when I'm looking at the different ratios for my other trig function values, some of them include an adjacent side, which is this length, and I don't have that written yet. So how would I find the length of that side? Well, it's a right triangle, so you can use the Pythagorean theorem. By the Pythagorean theorem, I know that 1 squared plus x squared is going to equal my hypotenuse squared. So that will be 3 squared. So now 1 plus x squared is going to equal 9. X squared equals 8. So x is going to be plus or minus the square root of 8. Now, we're in the first quadrant, and I'm looking at the sides of a triangle. So for this application, I want to be looking at positive square root 8. And one other thing I can do is reduce the square root of 8 to 2 root 2. So now I know that this length is 2 times the square root of 2. All right, I think it's time to fill in all of my other trig function values. The cosine of theta is defined by the adjacent side over the hypotenuse. Now I'm taking the cosine of theta, so I need to refer to theta. So I'm looking at the adjacent side, which is the side next to it, and so that's going to be 2 root 2 divided by the hypotenuse, which I know is a 3. So the cosine of theta is 2 root 2 over 3. Let's move on to the tangent. The tangent of theta, and again I have to refer to my angle theta, I'll be looking at the opposite side over the adjacent side. So the opposite side is 1, the adjacent side is 2 times the square root of 2. So I'll have 1 all over 2 root 2. Okay, moving on, let's take a look at the cosecant. The cosecant, that ratio is going to be the hypotenuse over the opposite. Well, the hypotenuse of my triangle we said was 3, and the opposite was 1. Now this can be reduced to simply a 3. Now, recall that the sine and the cosecant are reciprocals of each other. So 1/3 is the reciprocal of 3. Let's go ahead and take a look at the secant. The secant is the hypotenuse over the adjacent. So the hypotenuse again is 3, and the adjacent is 2 times the square root of 2. Again, cosine and secant are reciprocals of each other, and if you look at the values we get, they are indeed reciprocals of each other. Last one, the cotangent. The cotangent is the adjacent over the opposite. So the adjacent in this case is 2 root 2, and the opposite is going to be 1. And that can be reduced to 2 times the square root of 2. Tangent and cotangent are reciprocals. And if you look at the values that I got, they are indeed reciprocals. One other thing to point out. Many times you like to have your answer written without any radicals in the denominator. If you want to, you can take, we're going to look at the tangent as an example, you can multiply your answer by 1. And the form that 1 will take is the square root of 2 over 2. If you multiply these two fractions together, you're going to get the square root of 2 all over 2 times the square root of 2 times the square root of 2. That's going to give you a total of 4. That's just another way of writing the tangent where there are no radicals in the denominator. Both are correct. It's just a different way of expressing the answer. And you'll notice that you'll be able to do the same thing with the secant if you like. I hope this was helpful. Thanks.